When we think about what happened in the consumer space when we connected billions of devices, a lot of things emerged. We realized that data can get very big and complex, and that brings new challenges in terms of management of data and complexity of the analysis of the data. But we also found this real need for driving real-time insight from that data. It became really critical for new applications. We also saw that ecosystems were formed around the availability of this data and putting it into context with other data and actually solving new problems that maybe we didn't even anticipate. But becoming, or not becoming, overwhelmed by data was really critical, and this is something that Google has spent a tremendous amount of time and effort, as you probably can imagine, as these devices were connected in the consumer space. But just as importantly, the ability to drive insight from that data became really critical, and so automating that, using technology such as machine learning to be able to mine through that data in an efficient manner was really, really critical to our success as an organization and to many who have been managing big data projects. The reason I mention this is because the technologies that emerged from the consumer space are really the same technologies now we're sort of leaning into when we talk about the enterprise space and when we talk about manufacturing in particular. This ability to drive real-time insights, to use it to automate intelligence, to be able to do that at large scale, and, by the way, deliver very intuitive user experiences, maybe through natural language processing, through digital assistants, things like this. This new world of how we interact with machines is becoming really, really important. So the technologies that powered this evolution in the consumer space are the same technologies we're now leaning into as we look to this next revolution in the industrial world, or in particular manufacturing. So Internet of Things, the big data, cloud computing, machine learning, even some of the capabilities that we have in terms of augmented reality and applications and how you deliver and serve data. So just think about that as this digital backbone of manufacturing we're really now starting to lean into these technologies that have evolved and matured over periods of time in the consumer space. Now, the one thing that we learned when we connected billions of devices is that actually data is very, very, very important. It is really key to everything that you want to do. And becoming a data-driven organization is very important. Well, the good news is manufacturing data is not new to us. In fact, we have a plethora of data, maybe too much data, some might argue. I will not. I think it's great. We're a data-rich environment, but what we haven't done is break down the silos that we created in order to drive individual productivity. But now what we're finding is those silos are sort of holding us back from where we want to go for the next wave. And so breaking down silos of data is really, really important. Interconnecting this data in new ways to deliver value. Bringing every aspect of your business closer to your customer. And you do that through data. Being able to personalize your interactions with your customers. Being able to connect all aspects of the life cycle from commercial through to design and engineering to manufacturing, all the way out to the experience at the customer. Being able to build new business opportunities, engaging your customer in new ways. So this is really what it's all about in terms of IoT and data and a data-rich ecosystem. And so as we think about this end-to-end insight and this transformation around data, I want you to think about some of the interesting critical areas as we look toward IoT to help us solve some of these problems. So I'm going to start first with serverless scalability. We talked about the size of the data, the complexity of the data, and managing all of that on your own, and particularly as you start to connect and the data grows, is becoming really, really challenging. And so we've found at Google that enabling our customers to grow without having to do a lot of work from an infrastructure perspective is really, really key to success. And so serverless scalability is really important for us, and we believe for our customers as well. When we think about security, security is paramount, particularly for IoT, right? So now you have all these devices at the edge that we have communication and interaction with. how do you secure that so bad actors don't come into your environment where before you might have been protected, or at least you felt protected by some firewalls or data diodes or something like this. So security is really, really important, and you heard earlier today some of the talk around edge that we're doing, that we announced at this conference, and how important that is, we believe, doing that in a very secure way. So that's a huge component of what we believe is critical in Google Cloud. Intelligence everywhere. So this data and connecting devices is great, but you've got to be able to deliver business value. And that's where the intelligence piece becomes really important. And so I'm going to show you a little bit about how Google thinks about IoT from end to end. But last but not least, and just as critically important, is what is enabled with this new data is ecosystems around that data. And so we have ecosystems of partners, hardware partners, software partners, ISVs, SIs. And fortunately, I'm joined by two of our partners today to talk a little bit about how they see this evolve. But every time we talk to customers, they might use data for one purpose initially, and then they found that that data actually enabled them to deliver new business opportunities in new ways through commercializing that data or creating an ecosystem around that data. So just as important, that ecosystem of partners. If you think about IoT and the intelligent IoT from a Google Cloud perspective, it starts at the edge. Now, you heard in our keynote today, we announced Cloud IoT Edge. We also announced the Edge TPU, which is really important. We've had Android Things as an operating system at the edge, as well as running Linux. But this is all really important, particularly in manufacturing, where decisions sometimes need to be made in real time. We don't maybe necessarily have time to traffic all the data to the cloud. We may not want to backhaul all the data to the cloud for cost perspective. And so having an edge is really, really important and something that we believe very strongly in. So we've invested quite heavily in this space, and we're continuing to do that. And not just for hundreds of devices. We believe when you're really successful, you're going to grow from that first POC to millions of devices pretty quickly. And that's going to be important that your platform that you choose scales with you and does that seamlessly. And so this is something that Cloud IoT Core and the Edge do seamlessly for you, that scale from 1 to 1 million devices, and doing that in a manageable way. Now, just as importantly, you need the platform that can take that data, ingest the data, process the data, and use machine learning to automate that intelligence. And so one of the things about Google Cloud that's really important is we have that edge to cloud seamlessly integrated. So all of the services you might have heard about throughout the conference, whether it be machine learning or big data processing, it's all a seamless pipeline, right, from start to finish. Managed services, so we talked about serverless scalability, managed services from end to end. This is the Google Cloud Platform for Intelligent IoT. Really, really critical to success. So, end-to-end, seamless integration, managed services. This is what intelligent IoT looks like in the future. This is what intelligent IoT looks like within Google and for manufacturing. So with that, I want to walk through very quickly the 4 pillars of what we think of when we talk about intelligent manufacturing. And you will notice that in each of these pillars, IoT plays such a critical role. So we talk about the digital thread, right? Joining the data from all of the silos across your business, from commercial all the way through to customer experience, that whole integrated life cycle, feeding back with tight control loops. So we have a number of technologies that are critical in the digital thread. When we talk about new business opportunities, some people talk about how do you offer a product as a service, or how do you offer new opportunities within your industry. New business opportunities help you grow your top line while you're managing your bottom line. So we'll talk a little bit about how IoT is enabling that in our next speaker. Talk about the digital twin. How can we build and use all this data to create a virtual representation that we can then use for simulation, use for what-if analysis, predict what the next phase is going to look like. So digital twin is something that we think is very fundamental to this whole journey, and IoT plays a huge role in this. You're pulling all the data from real time in with the data from manufacturing and from design to form that tight loop, create a model. And last but not least, we have workforce efficiency. So how do you now leverage all of this data to bring real-time insights throughout your organization, whether that's in engineering and design, whether that's in the manufacturing and the shop floor, or whether that's when your field service people are out servicing the equipment. So these are the 4 key pillars, and we're going to now dive into those pillars through stories from our partners and from our customers. So I'm going to welcome Ganeep Bedi, who joins us from RealAir, and he's going to talk a little bit about their experience with Google Cloud.
Thank you, Jen. Hey, everybody. How's everyone doing? They don't make these for the turbans, so I have to use a handheld. So there's a challenge for all you geeks out there, invent something which, a few million of us can use in our turbans. But anyway, guys, thank you for taking the time. I'm here from RealAir. I lead all the commercial activities in North America. I want to talk to you about new business models. And like a lot of you, we've spent so much time in engineering and designing the right solutions. It's hard for an engineer like myself to take a step back and say, why? Why everything that Jen said is important, and why is it critical for our customers and the industrial manufacturing world to actually look at new business outcomes and new business models. By the way, show of quick hands, how many people from the industrial manufacturing world over there? Wow, good. Thanks, guys. Thanks for doing that. That's almost like 1/3 of the room. So I'm sure you relate to us. We have a booth down there if you want more detailed conversations. Happy to stop by. But who is RealAir? Why am I here? So we're a very committed partner to Google, and I think what we are is we have about 10 years of experience, which in this space it makes us veterans on how we actually get data and transform industrial and manufacturing environments. We are about 200 people strong. Germany, headquartered from an R&D perspective, and of course spread out globally in the Western Hemisphere. What we focus on is enabling the industrial customers to stay relevant by creating OpEx, or operational expense models. So I'll probably have one slide on technology, and then I'll talk more about how we are actually using multiple technologies that Jen and then what Ryan will share, stuff like that, into actual business transformation. We focus a lot on the edge and getting data from actual machines on site. We focus on a lot of artificial intelligence using tools like GCP's tools, but more industrial focused, right? So I'll talk to you about that, but just to kind of give you a sense. And what we do, which is very interesting, I don't know if you've seen this before. So on the top right in the red, we talk about technology, which we leverage a lot of technology from the Google Cloud Platform, and we have some wrappers that we add on top of that, which actually puts this together as a SaaS. So there's a lot of infrastructure as a service and PaaS services, which we kind of capsulate into a solution. So visualization, AI, a lot of focus on the edge. But that's where we started, and we realized very quickly, which I'll show in the next slide, and for all of you guys in the industrial relate to this, it's hard to do this transformation because there's so many different problems to solve, especially the legacy equipment that you have, right? So we actually developed a very large and qualified professional services team, which is the other red in the bottom, to say, hey, you need to pick the right sensor kits, the right frequency, the right specifications. You need to actually customize all the tools which are available for specifically your environment and create an MVP and beyond. So I think that's the other thing. And the other two things in gray, which is very, very interesting, is there is risk. From your management perspective or a C-level perspective, there is risk in doing this. I've been doing this for 140 years or more. Why should I change? And I think that's where one of our investors is the largest reinsurance firm, and we actually create models to give the data, which Jen described beautifully, data is the new oil, to insurance companies to smart their actuarial models. So actually to guarantee outcomes. So if you're looking at an outcome, with the backing of the insurance and the data that we have, we can actually guarantee this. I'll give you an example a little later in my presentation. So that's one part. And the second part is, a lot of you will appreciate that if you're going from a CapEx model where you sell a lot of equipment up front into as a service model, there is a decrease in volume in the short term, right? So how do you kind of finance that, especially for smaller organizations? So that's interesting. So we're enabling the whole industrial and manufacturing space with a combination of insurance, finance, services, or what we call delivery, and technology. A lot of the technology components, which were discussed by Jen. And and why? I think this is an interesting problem because we also focus on the mid-market. The top 5 challenges that we see with CEOs, and I'm sure you'll relate to this, or C-level, is like I said, there's a risk. There's a financial risk to do this. A lot of people in the industrial world are really good at what they do. They make machines, or they make use machines to make widgets and make equipment, but they don't have digital and IoT technical skills. And by the way, these skills are really new. There's a lack of digital strategy too, because it really has to fundamentally change the way you're doing things, especially if you're trying to sell as a service, and I'll describe what that means. And of course, there's a lot of legacy infrastructure. So that's where it gets complicated. It's not only a software and cloud problem. How do you roll out these retrofit kits across millions of devices? How do you make sure if something goes bad in this asset, you go and replace it? So you need the whole infrastructure of distributors, people who can stock hardware. So it's kind of getting all that pieces together, which a lot of industrial companies are not used to, whereas a lot of the hardware networking vendors are. So, like I said, I'll show you one technical slide and get back to what I was saying. But from a tech perspective, like you see, similar to what Jen showed, just less number of services. But what we do today, we have an edge solution, which is our IoT gateway agent, which almost 99% of the times we use. So I'm so glad Google's actually thinking of the edge that seriously, because almost every industrial customer for latency, I think you talked about latency and decision-making at the edge for cost, and for certain customers, specifically overseas, it's also anonymity, right? What kind of data do I want to send? I know we work with bottling plants, and Coca-Cola's bottlers would never allow you to tell the number of bottles that were actually manufactured in a plant. That's just a no-no. That's their business model, right? So I think that's why edge is important, to actually make sure you're sending the right kind of information. And we use IoT Core as well as PubSub a lot, and starting to use a lot of other GCP services, which kind of sit on top of our software platform. And in all of that, I'm talking about what is equipment as a service. Why are we really doing this? And I think maybe I'll go to the next slide and come back. I don't know if you knew this, but fun fact: 80% of the expenses is for running a machine, not to purchase a machine. So anybody who uses a machine, heavy industry machine, or in manufacturing environments or other environments, you buy a textile plant, or you buy motors or pumps or elevators, you spend more than 80% of this in the life cycle of the asset on maintaining it, on servicing it, on putting spare parts, on actually break fix. And of course, you're getting squeezed, or the machine builders are getting squeezed on margin up front. So the idea is, how do I play in that as a service servitization model for that 80% additional revenue versus just selling the machine up front, right? So that's the problem statement. And I think how we're solving it with IoT as well as the business model is, how about you give your asset for free and you actually charge the customer on the utilization, right? So it's not a lease, right? Just to kind of clarify. It's actually a model where you actually charge per coffee cup make, which is actually a true statement, per aluminum part treated by a BMW or a Ford. So how do you actually charge per utilization? Which means SLA and warranties are important, because now somebody else is maintaining your asset in your supply chain. You need to make sure that bloody well works, right? And works with a 99.9% efficiency. You want to make sure you're getting data out of that, so that you can remotely diagnose if any problem occurs. And you want utilization, so you can actually build a customer based on utilization. And that's where we see the real value of IoT. Coming in to get all of that information, to do predictive maintenance, anomaly detection, make sure the asset runs, give SLA warranties, as well as actually give you the real utilization so you can forecast how your revenue would look like, a lot more predictable. And why insurance comes in this is, like I said, it's important that the asset runs 99.9% or more, and that's where insurance can come and give guarantees if they have that feed of data of how this asset is running. So that's really what the big innovation we're seeing in the market, using IoT and IoT Core. And I'll leave you with one detailed example. I spent a couple of minutes. It makes it real, when you're looking at it. So this is a company called Allovation. We actually have a replica of this heat treatment plant in our booth down there. And this is running on GCP today. And the whole idea here is, previously customers had to ship their parts, their aluminum parts. And by the way, fun fact, I don't know if you guys knew this. 6 years ago, very little parts in the cars were aluminum. Today, it's 80% or more, right? So there's a lot of aluminum in every car, right? Or aluminium for people outside the US. But the whole idea was, hey, you have to ship it somewhere, it gets treated, it comes back. The first innovation our customer did is make microfactories. So made these, containerized, which can go on ships and trucks. factory which could treat the aluminum parts, right? But the challenge with that is the two big challenges. Number one, how do you monitor these and make sure these are running? Because these are not on your factory now. These are on the OEMs, BMWs and Ford's parking lots. And second challenge is, BMW and Ford said, I will pay you just for the parts treated. I can't forecast anymore, in my supply chain long term how my C-Series sells for 10 years. So what we're doing for them is basically, heat treatment as a service. We're integrating with their existing infrastructure, which happens to be Siemens in this case, because it's in Germany, Siemens PLCs. We get all this data in from our edge solution in the gateway, and then what we do is we integrate with both the billing systems and with AI to kind of predict if something is going to happen before it happens. We've increased the demand planning by almost about 40%, actually. And we've been able to diagnose in 2 weeks in advance if something fails or before something fails. So almost 16% more uptime. So it's a real case, and it's a real case in a very old school industry. And Mr. Belte, the CEO, expect he'll make about 40% more revenue just by selling this as a service or utilization in the next 2 years versus selling these upfront. These cost about $1 million, but instead of selling these $1 million upfront, he's going to actually put these for free and then charge utilization based pricing to BMWs and Ford. So this gives you an example, and you wouldn't have think of it, heat treatment of all things, which we're using technologies and everything else for. And the last thought, and I'll pass it back to Jen, is lots of ways insurance can help. And I think this is new for you guys, but when you and your management are thinking of implementing digital and IoT, think about this model where insurance can back you up to both give you a safety net for as a service model, so take the financial risk away from their books. That's what they do. Guarantee outcomes, be it SLAs, be it uptime, be it whatever the outcome that you're looking for from a business perspective. And we're so confident that we actually give you a money-back guarantee. So if you want to do a project and get started, and if that fails, they're actually backing us up to give you money back as a customer. So just insurance is playing in this a lot, which kind of makes sense to us because we're in this world. But with that thought, I will pass it back to Jen, and I'll be around for questions right after this session on my booth. Thank you. Thank you, Jen.
Yeah. So it's great. So you remember the 4 pillars, and that was really all about new business models. So now I'm going to introduce Ryan Smith, who's a VP of Product and Engineering for a partner Site Machine, and he's going to talk a little bit about this idea of the data-first paradigm, probably weaving in a little bit of the digital thread and the digital twin and how they deliver that in their solution. So Ryan, over to you.
Very good. Thank you, Jen. So a quick background. I'm going to talk more on technology in this talk. Need's doing some amazing things with RealAir on the business model side. I'll talk a little on Site Machine. So we're a venture-backed company. We've been around for about 7 years now. Started with a founding team that had done some big data and open source technologies. Many of you might be familiar with Slashdot. They founded that open source site in their dorm room in college and then went on to architect SourceForge, but also just happened to work in manufacturing growing up. So control systems engineers working in that space, and then formed a team that said, hey, let's combine some of these technologies together to service customers in manufacturing. So I'm going to give a rapid-fire kind of product demo video that's going to go very quickly, and then talk about our technology a little bit. So we acquire data from all sorts of different systems, these silos that Jen mentioned. Streaming data comes in, and you can see here time series data, ERP, MES, but not all of that is usable until you add that context layer. So we have browser-based tools to set up these stream pipelines for manufacturing. So it's a manufacturing-centric product in which we have automation and AI to auto-detect data from your systems, help you model it in order to ensure that it matches what you expect from somebody that's familiar with your operations. And then things like dashboarding. So if I want real-time dashboards to show my operators how they're doing relative to set points or KPIs, I can create those on the fly, drag drop, similar to BI tools. So that's at the line level. All the way up to corporate level, you can see remote facilities. So in this case, we have OEMs that see everyone, and then each one of their suppliers can see the machines on their line or their few facilities. And you can scroll around and do things like, what's the output looking like, or am I going to meet production targets? We also have out-of-the-box analytics. So you can see here, we're optimizing and doing root cause. We're correlating all of my bad parts with the process parameters that created them. And we can surface up here and say, in this instance, your maximum injection pressure on this machine is correlating with bad parts that are produced later. So we have a lot of these out of the box, but it's also extensible. If I want to deploy new analytics on top of it that feel quite tailored, we've solved that data problem for you such that you can quite quickly use APIs to do different types of analytics. And that could be investigation analytics, so to dig in here, show me correlations, and let me click on this and drill down and click through, or operational deployment analytics. Every time this happens, either send a signal back, notify me on my phone so I can go fix this. So I'm not getting into a lot of the business use cases here, but very flexible platform, and the core technology solves that combining and contextualizing data for the manufacturing vertical, which for customers that are scaling, that has been their rate limiting step. They have lots and lots of data, lots of systems in place already. How do I make sense of that to drive business value? So the underlying paradigm, I'll talk a little bit on the architecture side. We talk about either an app first or a data first paradigm. App first is I have a client-side application, I'm going to push this down and expect all of my facilities to conform to that. The data needs to come in the same structure. And companies that are thinking this way are having a really hard time rolling out because you have lots of legacy infrastructure in place, and they're in this zone where they're waiting and saying, when I get everything standardized, I'm going to put this technology on top of it. They're going to be waiting for quite some time. The rate at which things change, and if you look at the footprint a typical OEM manufacturer has, it's very hard to get everything standardized. So you either have to assume that the world's going to conform to you and your technology, or you have to meet them and be flexible and conform to them. So when we talk on data first, it means take the data in from all of these different systems, these dissimilar systems that are already in place, and get it contextualized into a base model. So that digital twin that Jen mentioned, get it into that model such that you can work with it. And that is the core step for doing this in manufacturing. If you look at IoT wins, you see smart city in which people are deploying to lots and lots of the same meters, for instance, for parking. Or you see kind of jet engines and things like that. For manufacturing, if you think about the amount of robotics or assets that touch a car as it goes through the line, they're all different. The data coming off of them is different, systems in place are different, and especially when you start thinking about combining them with your ERP data, your MES data, you really have to be flexible and take all of that in and combine it. So I'll talk briefly on how we do this. We can run our software anywhere, but a typical deployment, we have both edge and cloud in play as well. So on the left side, that acquisition layer will pull data off of factory floor devices. We can do protocol translation and kind of extensible plugins, but for the most part, we talk to the common things you'll see in a manufacturing plant. That all gets compressed, securely transmitted out, and then most of the time, the analysis and visualization will run in the cloud because our customers are rolling this out to tens of facilities. This is the key step. We have this base model that's a data model that can handle any arbitrary manufacturing data. And so getting data into that model, if you have a known target, automating, getting that data contextualized in, you can put automation around it and use techniques like AI to classify your tags or kind of auto-contextualize. And then you can also have standard APIs out of the back. So every single facility, you'll have a known API that your data science teams internally or your OT folks can consume from the browser. So getting that right level of what's the same across all my facilities and what's different is really important. This is an OEM customer, as I mentioned, they see across their operation. So we're collecting on the order of somewhere upwards of 10 billion data points for them each week. These are stream processed out of their facilities. Each one of their supplier is seeing their data contextualized in a browser, and then the OEM can see across the board. And when you get into business model and incentive structure around this, it requires a lot of trust between these parties and figuring out what can I share and what happens and how do we work together on this. But if you can do that part right on the people side, the tech's in place to provide enormous value to both parties, the suppliers and the consumers of these goods. So I'm going to talk a little bit about tech. When we talk to customers, we don't talk about our tech at all. We talk a lot about our product and how can it fit their needs to provide business value. I'll talk on some things we've learned. I did a quick Google Trends search on IoT, and when we first started doing a lot of these edge deployments, it was not a buzzword. Nobody was searching for it at all. And it's blown up, as you know, there's whole sessions on it here. But it means we had to learn some lessons along the way on what works at the edge and what doesn't. So we started off torturing cloud tools to do things at the edge, and they work to varying degrees. The first tool we used Ansible, great tool for some cloud deployments, but it's push-based. So fortunately, we were still under 100 kind of edge devices deployed throughout Greater China and Vietnam, and we realized this is a bad tool for this. If half of them are online, if you have an edge device on every robotic, and half aren't, you got to make sure that you go to them and hit them. So we quickly rolled over onto Chef. It's a pull-based tool for cloud deployment, and devices phone home and get these things. And this seems obvious, but in the early days, a lot of these lessons had to be learned via bruises. And so we've deployed hundreds of devices on top of Chef, and it's worked fine, but it's really exciting to see these purpose-based tools that are built for edge device management. So IoT Core and the like that are doing container deploy, all of your device orchestration, all kind of from a unified screen, and thinking through all of these challenges up front has been fantastic. And we're just at the early stage of this, but I can't wait to see where these tools go. I'm also going to talk a little bit about Kubernetes. So we've deployed on top of Kubernetes in GKE, and it's a huge scaling lever for us. So when we think about the needs that we need to do to service our customers, it's been an incredible accelerator both for our internal development and for our rollout. So if you talk about doing, tiered deployment to lots and lots of plants very quickly, maintaining that velocity inside of our customers is incredibly important. Your internal champion needs to be able to go fast so people don't feel like it's dragging on and taking forever. And there's a lot of things that go with that, getting access to their data, setting up streaming pipelines. There's a lot of tech and automation associated with that. And so I'll give kind of rough cut architecture overview. Every customer has an isolated namespace on Kubernetes. So they have their own version of the services running. Each pod can run things such as persisted volume databases, ETL services, web services, but then we can very quickly pick up that namespace and clone it if we want to test some new code, let them deploy an analytic without affecting production, or alter a machine type that they have across all of their facilities to try and join new data to it from a different system that they didn't start with, for instance. So I'll show very quickly. This is an internal tool. We don't usually talk about it with customers. Heath Albritton and Josh Brown from our team on infrastructure developed this. And what this does is it allows us to manage our Kubernetes clusters. So we have all of our customer environments available in here. And if we scroll through, I can see kind of what is the environment name on this particular cluster, what code is deployed there for various repos, what is it tagged, is it a production or development instance, and inside of here we can see what version of our infrastructure and who owns this. So as you start to scale out, who's made a given environment, who needs to be in charge of spin up or tear down, all of that's available just within a web browser. And so if I take an example customer, if I have this NSG, for instance, environment, we have tools inside of here that enable our internal teams. So one of the things we really focus on is extending our technology lead. If I need to get at different services attached to the Mongo container, attached to any of the software I'm running to debug, this is available to our team, and that helps us, as we onboard new engineers, extend our lead in terms of a technology advantage. We also have things like, what's my deployment history? What have I pushed there? Or, what deployments have been run on a given environment? All of that audit trail that you'd expect from an enterprise system if you need things to know what state they're in at any time. And then finally, links out for every single environment to isolated monitoring tools. So if you have Prometheus or Elk or things like that, or Grafana here, you can take a look and see, here's the metrics for this particular instance and this particular customer. So I'll talk really quick about workflow. Say that you have a customer and you want to test a new analytic or new feature, or you want to make a change to what they've done with their data pipeline without affecting production. We can clone that environment. So in this case, I'm going to say, take this customer environment, give me all of the data that comes with it, and keep streaming data in as it's coming from all of their edge robotics. And then I get a new URL that I'll be able to view that in. So this goes into our system, it spins it up, and you can see kind of it's accepting this request. If we go back to our front end here, we can take a look and see that it's creating that environment. It takes a few seconds here. You can see somebody else has actually done a deployment since I started. It keeps a log of all of them. But at completion, I now have a nice isolated environment that I can manage their data, try new things, deploy code that's untested yet, change their data pipeline. So once that's in place, as I mentioned, I can go deploy whatever code I want. It'll resolve any artifacts. You can pin a branch to it if you're doing continuous deployment. You can select a specific artifact if you want to test something that you want there. And so all of this is just set up to increase our velocity and allow our internal teams to provide value for our customers faster. So you can see kind of the end state here, isolated environment that has all the tooling that I mentioned earlier, but you can do anything you like on it without affecting production. And then when you get your data right, or the changes you want made, those smash in quite readily to the prod environment. So I'll share a couple thoughts. We've been doing this a long enough time to see what's working and what's been challenging. One of the things that we really look at is if technology leadership is not bought in out the gate, it is a real struggle. You need IT and OT at the table. If you don't have functional alignment from the top of the house, it's going to cause challenge in terms of the rate at which you can roll some of this out. And kind of the POCs, without thinking about how you're going to scale this on the tail end, the organizations don't respond well to that. It's a huge change management exercise to actually get this digital technology penetrating throughout your company. And so you really need to think about, assuming that it's successful, what are we going to do as an organization on the back end? And that's irrelevant of the tech. So I'm a huge believer in technology. It's a focus for me. But we've really learned as a company, figuring out the partnership and rollout strategy and what in-house teams do at our customers, what we do and what infrastructure teams do is really important. So here's what's working. As I mentioned, the tech's the easy part. Getting the orgs right is challenging. If you promote from the top of the house innovation and encourage risk-taking and trying new things with this technology, we've seen incredible response. We're now in a zone where 2 years ago, people were trying this out, and we had a few proof points that people saved some money or made some money. It's completely shifted in the last year and a half or so, in which orgs are scaling this out quite rapidly. They hit the ground running. They know once I have the value proof points for my org, these are where I'm going to take the technology to. And that's just a game changer in terms of scaling mentality on the side of the manufacturers. And finally, partner. I'll really hammer this. True partnering is hard, figuring out what do I want to own, what's my core competency for my OT team or IT, what can cloud services do, what can kind of third-party platforms do. Looking at that up front and saying, what do I want to build and what should I partner on has been a huge accelerant. This is an exciting time for manufacturing. I think this is going to be incredibly transforming for the industry in ways that we've not thought of, and it's just getting the traction at the scale that everybody started to talk a long time about and dream about, but it's actually come into fruition. So I'm incredibly excited and really appreciate the opportunity to talk with you.